Awesome. Here we go. Hey, good morning. Welcome to day, whatever it is for you, of the COVID-19 pandemic and our discussion of multicast. Okay. Wireless, new topic. It's kind of the same, it's kind of not, right? Wireless is very similar to Ethernet. Yeah, this gets into a lot of wireless topics. Let's put it that way. So why are you listening to me? Well, the key thing is now about 6 years now of designing, implementing, and supporting multicast networks in an enterprise. So WAN, right? RPs, large stuff, not just sort of like, hey, I turn on my switch and it works great. So that's the important part. And then in terms of this, yeah, I've actually gone off and got my wireless certs, not an IE yet. We'll get there. Yeah. So, and you know, if you want to look at my claim link, you can see my little badges. Okay. Cisco isn't, this one, the net on this is not endorsed by or paid for by Cisco, and neither is it revealing confidential business information. There you go. Multicast is group communication, where a group is 0 or more computers. It's old, it's 35 years old. It could drink, it could smoke, it could, you know, get discounts on insurance. It's not young, not old enough to get to join the AARP yet. For non-Americans, American Association of Retired People, you have to be 55 or older to join. And I'm going to talk about this on unified wireless. So a autonomous access point is a very different animal. There's a lot less complication to it in some sense, but this is going to focus on unified wireless, okay? And we're going to look about what kind of options, how you're going to make this thing work, okay? Triple constraint, always talk about it. Do I have any new ideas? I don't know, but you know, look, and they're telling you they need to up the quality a lot. Probably need more money, or you're going to spend more time on it, right? I can't do that if you want it by next Monday, I can't deliver that kind of quality. Can't do it, right? They're going to argue, but as I've said, you know, this is a 3-legged stool. You change one leg, the thing's going to do a serious tilt unless you adjust at least one, if not the other 2 legs. Okay. Multicast for unicast, right? One transmission per interested stream, or one stream per interested link, versus every receiver has to have its own stream. That view you've seen a bunch of times. Just this is from the perspective of a sender. If I've got to support more and more and more senders, I have to provide more, I have to take more and more and more bandwidth. Okay, and this also doesn't include things like memory, because I have more sessions to keep track of. There's a lot of other drag on the system. As we've seen, multicast is pushing a lot of this group communication out onto the network. So receivers are registering to say, hey, I'm part of that group, or I want to be part of that group, right? There's a mechanism that the sender doesn't have to find the receiver. There's a lot that the multicast provides, and that's what's use. And when I finally do my IPv6 module, well, they've just said, let's skip broadcast entirely and go nothing. We're going to do it's a unicast or multicast or nothing. There is no broadcast as an option. These ranges, right? And these are just good to know. Some of them like source specific, and there's some other ones you can look up like GLOP for using multicast across the internet. But if you're doing some sort of packet capture, you're doing NetFlow or whatever, and you see these as destinations, you're like, oh, that's a multicast. And you know that you can go back to the IANA registry if it's particularly in that lowest range, that 224.00 or 010, those ranges are registered. And you'll see, oh, okay, that's probably this application. Okay, and then this thing about MACs, and this is kind of an interesting question. And in the context of wireless wasn't designed for peer-to-peer, except for ad hoc networks. But everybody's sending to the distribution. So if you know wireless, you know that a packet can have up to 4 MAC addresses. So it may have, this is the MAC of the AP that I need to send to. This is the one I'm associated with. Here is your packet. It may have the ultimate source, or the source, or the ultimate destination, the for the packet itself, particularly if it's on that same segment, like, hey, this is the guy I wanted to give it to. Okay, I may have the originating source, but I may also be saying that, and by the way, that originating source came through me in a mesh network. So you can have up to 4. So this MAC is not necessarily, is probably not going to be what's the destination from the original sender. It's probably going to be back down the stack to say, yeah, this is, hey AP, I have a multicast packet. You need to deal with it. It's very demanding. So that's how that works. It's pretty simple. You turn it on. Boom, check, done. Right? You see there's IGMP snooping. You see there's MLD snooping, which we talked a little bit about. That's for IPv6, Multicast Listener Discovery Protocol. It's good to turn it on. It's very useful. Those are default query and timeouts. And then the other piece of it is, so that's the basic. I've turned it on. I have snooping. So what'll happen now is that the WAPs won't send traffic that they don't need to, because they know they have clients that want the traffic or don't. The other piece is this one. So how do I deal with the multicast packets through the distribution system? And Cisco's recommendation, and we're going to go over it, is this one, the way it's set up right now, multicast mode, multicast. And we're going to go over in detail what that actually entails in just a second. And they particularly recommend it if you're doing more than 50 APs on a single controller. So given the kind of the price points on Cisco gear, that if you're running like 4 APs, it's probably not economical to run Cisco Unified Wireless. If that's your entire enterprise is 4 APs, probably not economical. Maybe the Meraki would be a better solution for that, because of the cloud. You don't have to buy the controller. There's a lot of expenses that go into having those wireless LAN, the LWAPs, okay? But for 50 or more, they're like, definitely do it, okay? If you're doing broadcast forwarding, and there may be some reasons you do that when you turn that on, how it gets sent through the distribution system from the wireless LAN controller to the other controllers is using that multicast mode. So it'll multicast the traffic or unicast it depending on what you told it to do. Okay. And I'm going to say this in a couple different ways. All WAPs must be able to receive the traffic on the defined group. So there's going to be some things we need to do. So when I set up that group address, I picked it, and you notice it's from the administratively scoped range, that unless I'm just a very, very flat network, so everything's meeting at a common like distribution or collapse core or whatever it is, that I'm going to need to have an RP, and it's going to need to advertise that address or that range. Okay. So, and the APs need to know where the VLANs that the APs are on, those SVIs need to be able to get to that RP as well. Okay. Multicast mode unicast sends multicast packets from the WLC to all APs using unicast. So that idea of 50, they're basically saying, look, by the time you start doing more than 50 APs, you're going to spend so much overhead of getting the traffic out to all these APs. And think of it, if I have one of the bigger controllers that I have, like 500, if I have close to 500 APs running on it, it's a lot of streams. So even a very, very small multicast stream could take a lot of bandwidth from the outbound from the controller. Okay. And I said it requires a group address. Now, whether it should be unique to that controller or if it's a highly available pair, it's a good idea. Okay. There's a little star on that. That the bad part of using the same address is that you're now sending, this is all IGMP v2, So we all say, I want this traffic. So I'm going to send it all over the place. Now, if I'm an access point, I may know about a dozen sources now for this group. I'm going to drop all the traffic that's not from my AP, not from my controller. However, why do I want to take that traffic? I don't. But there is a weird, and this is the third point down here below the unique address, is that we share VLAN. If the controllers share VLANs, that multicast traffic, they're going to see each other's multicast traffic, and they will purposely traffic that's destined for the CapWAP groups, which is what it's using to transit this. It's the ports, those UDP ports, it's using to transmit this multicast traffic. If it sees that from other than itself, the LAN controller drops it. But if the packet gets fragmented, the second fragment doesn't have the port number. It's basically telling the other side, the first packet's going to be marked, I have fragments, and I'm fragment 1, and the subsequent ones are I have fragment 2, fragment 3, with offsets and all that good stuff, right? So you can put it all back together when it gets to the other side. But in this case, it doesn't know that this is a bad packet, it's something I should be dropping. I don't need this, and it'll forward it through its system. And it's just junk. It's junk traffic. It's a part of a packet. So later on, you're trying to reassemble all that stuff, and it's like, I don't have part 1. What the heck? Yeah, just not a good thing. And you're going to use that administrative range. Yes, you can do anything you want, frankly, but the problem is you don't want to have the same as another group. So with another application, but here you can keep it more unique. And if in terms of scoping, if all my APs and my WLC are inside a campus, I can use a range that's unique to that campus. I don't have a range. I don't have something that's going to be popping out and needing to go anywhere, right? The RP is local. I do everything, keep the traffic local, okay? They recommend against using these two ranges I'm showing you there, 239.0.0.0 and 239.128.0.0, because on the MAC layer, layer 2, those packets are going to look like that 224.0.0.0/24, okay? Because remember, we only have 23 bits to play with, so it doesn't matter if the first octet is just hidden completely. I don't know what it is. It could be anything in that multicast range from 224 through 239. And the second one, 0 and 28 look the same because it's that 8th bit, though the very first bit to the left is the one that we take as part of the header. So you can't, those things will look the same as that. And so I don't want this traffic looking like EIGRP or OSPF or whatever that may need to be doing stuff locally, okay? And I said it already, don't use the same group address as another application. Just because with V2, IGMP V2, that it's not distinguishing the different sources, everyone's gonna get this traffic, and why take the bandwidth and why have the processing load? Because remember, what it's gotta do is it gets the signal, gets the traffic, it looks at it first. Okay, so IGMP snooping, maybe it already didn't deliver the traffic, but assuming for some reason it's getting that traffic otherwise. But in these cases, it's going to ask for it because it's the same group, right? So IGMP snooping, you want that group, I'm sending you that group, okay? Second, MAC address, well, that's the group I want. That's the same kind of MAC, great. IP address, yep, that's the same thing. Then it'll probably diverge, it'll be a different UDP port. Or in the case of these routing protocols, if I did that, which would be really insane, this should be protocol OSPF, not protocol IP. What? Drop. Why do I want to do all that extra checking? Just use a different group, okay? And this one kind of hinted at this. If you have a boundary, if you filter whatever, the group you're using between the APs, and that's the management interface on the WLC and the APs, that group has to be able to make it all the way between. If there's a boundary blocking it, you've got a problem. This can be relevant if you have a controller that you have a nice campus, then you have these ancillary buildings that are connected via WAN links, not direct fiber attachment, and you've got a block on at the WAN side. Now, maybe you don't want the multicast traffic on these sites that are also using that controller, and you're okay with that. As far as I know, there's no fallback. It doesn't go, oh, I can't get to those APs, so I'm going to unicast it. It just goes, I'm multicasting. You don't get it? Your problem. Now, obviously, if you have something where it's like, well, every time they go over, where they don't get the group pages off of Sarah, if they're at this ancillary, this outbuilding, like, yeah, because that's on the WAN, and doesn't work. Yeah. Okay. How are we doing on time? We're doing great. And then this is about enabling on the LAN. Now we're really just talking about, well, at first we're really just going to talk about the multicast mode multicast. This is just getting multicast traffic or that redistributed broadcast traffic, getting it between the WLC and the APs. So PIM is turned on the WLC management VLAN. I could probably cheat that if I had the APs sitting on that same LAN. And I've seen designs people have done that. And it has the weird advantage, if you're a flat network, you're all layer 2. The weird advantage is I stick an AP on there. Well, I don't have to have the DHCP option set. I don't have to do much of anything. It's going to attach to it. If it's the only controller or it's just an HA pair, it's going to attach to it because I start doing my thing and I'm like, oh, hey, there's one. You may have something where you're going to wipe out an old preferred controller if it can still get to it, but it will do its thing and find your controller because on the same LAN. It can do it through broadcast mechanisms for IPv4. And then where the WAPs are connected, those VLANs. Now, that creates an interesting thing to consider, okay? So if you normally sit on your user LAN because it's just convenient. If you do that, then your user LAN has to have multicast turned on. You may not want that. There may be stuff that if they don't need it, don't do it, therefore turn it off. So you may want to think about doing separate VLANs for the WAPs downfield, okay? And Cisco's note says they use IGMP v1 or v2 to connect to the group. Now, I'd be really surprised if any modern LWAP is using IGMP v1. I'd really be surprised. It's been supplanted for 2 decades. So I kind of doubt it, but that's what it says. Okay. For all multicast, this is pretty simple. On EWLAN where multicast is desired, PIM should be turned on for the attached VLAN. There are some things to know. Multicast will not work over a guest tunnel. So the idea is, hey, I've got this layer 3 and I have the Ethernet over IP tunnel that connects back. Yeah, multicast is not supposed to work. Now, I'd be careful in my designs just to make sure that, if I have the guest network hit like the user LAN has multicast turned on, but then it's tunneled back, just to be on the safe side, I'd want to have it pop onto a different LAN just because I don't want it to work for my guest traffic. And really, I don't want it to work for guest traffic. I don't. It says avoid those are your CapWAP ports. Avoid those for any multicast app. So the if you have a choice and you're setting something and you're doing the, I'm going to change the default port because then it's more secure so no one knows what it is, right? Which is not a bad plan, right? It isn't. I've seen that plenty of times. Don't pick those two. If you randomly plunk those out of your head, you might just start thinking, aren't those CapWAP? It's something about not you. Yeah, don't use them, okay? And the multicast capabilities do vary on the controller model. So some of the ones that are designed to be the backends for the switch, like 3850s, yeah, they have different capabilities. So I'm really focused a lot on like the 5500 series, the 3502s, the 20, what are those? The 2502s, um, those, which is what you most commonly see out in the field and most of the designs I've been working with. I know a lot of sites were just never really happy with the switch modules in the 3850s and like the Soup 8s. So they didn't. They're still, you're still deploying those. Just if you have questions, you're straying out of there. You're getting the 8500 series, the 7000 series. If you're doing the virtual, start taking a look at what those different capabilities are. And let's see, how are we doing for time? Time check. Okay, we can go forward a little more. And from a sender being out on the distribution system, out on the wireless LAN, the multicast is forward over the cap up to WLC. Then the WLC is going to kick in and do the work. Okay. The controller is the one who's tracking. You see, that's where turn on is which WLANs need particular groups. Multicast traffic for any WLAN is forward to all WAPs that have that WLAN enabled. So, I have, say, 2 user LANs, one of them multicast, one not. Well, if I have some AP group and they don't have that multicast enabled, I'm not sending traffic to them. I'm not sending traffic because it knows you don't have that WLAN. I don't need to send this to you. Okay. If the same VLAN is used for multiple WLANs, and that's legit in some designs, you may have a need like for PSK, but you want to drop into the same LAN. So you have a PSK here. Oh, only these guys can use PSK. The other ones are going to use, and maybe I have the PSK, maybe I put some ACLs in there to put some more controls on it, but they both do it, and I have another with 8021X. Yeah, they're both going to get that traffic. They're both going to get the multicast, because the WLC can't figure out, well, that was actually meant for that WLAN, not for this one. Okay. The WAFs will only forward multicast they receive from their controller, nobody else's controller. That seems kind of straightforward, but important to mention that if my controller doesn't forward it, I'm not going to forward it. And there may be reasons that's not happening. So say I've got big hospital, lots of APs, and I've got this, I'm doing this sort of odd even. So this controller pair is doing this floor, then another set of controllers. I do that. And hey, on the even floors, they get the broadcast, and the odd floors, I know what's going on. That could be that the multicast traffic isn't going to do the other set of controllers. Okay. Multicasts from wireless clients are copied by the WLC onto the VLAN, as well as forwarded to the WAPs using CapWAP. So just to be clear, the WAPs are using CapWAP. We're dumping the traffic onto that VLAN. So source sends traffic to the AP forwards it to WLC. WLC is going to be sending it out using CapWAP to the APs, but it's also for whatever VLAN that thing was on, it's copying a packet down onto that VLAN as well. Right? So it's got those trunked interfaces, or you could have individually assigned interfaces depending on how you designed it. But it's mostly trunks in the designs I've seen, and my designs are always trunks. Drops it onto that VLAN as well. That's how wired clients are going to be able to hear this, okay? For layer 3 client roams to work, the foreign controller must issue an IGMP report to move the traffic to the new VLAN. So I do a roam, I pick up this new IP address on the foreign controller. Yeah, I need to, that controller has to know about what IGMP groups, what multicast groups I want, and has to do a report up to that interface to go, hey, I got another client. Now, obviously, if it already knows, if it already has getting that group for other reasons, there are other clients who want that traffic, it's pretty easy. If it's the first now on this AP, well, I'm going to now start adding that traffic to that AP. If I or excuse me, that AP is now going to start shipping that traffic out. Oh, hey, someone wants this traffic, I'll give it to you. And why is that last piece important? The AP is not withholding traffic if it doesn't have clients that want it, and that's just because wireless is a very shared medium. This goes back to the days of the original Ethernet. We all hear each other. Any traffic that gets sent, we all have to hear. We even hear stuff that's on the channel that's not even our SSID. We hear it, we can't do anything with it. It's not destined for us. We don't understand the encryption on it, so it doesn't make any sense to us. That's fine, we're going to ignore it very quickly, but that radio time you can't get back. So if you send stuff you don't need, that's a bad thing, okay? Okay, multicast mode over multicast. There's a group ID that gets attached when we're bundling this traffic, because remember we have this one group. This one group is how we're distributing, so I have to be able to tell the AP on the far end. I need to make sure as I encapsulate all this that it needs to, yeah, this is going for this WLAN, it's this group, go. And then, yeah, cap WAP it's sent. Use multicast group define. So you've told it what group to use, that's what it's going to send. That's what it needs to send with. And the WLC, this is one of your checks, right? So I have like a remote switch somewhere and it's got a layer 3 on it and I've got APs hung off of it. If I do a show IPM route, I should see the group. I should see a star comma G for that group for all the APs that are hung off of it. And I should see the S comma G with it, the WLC being the unicast address. I should see that. That means that everything is working properly, right? And my outgoing interface should point towards the APs. My incoming on that source should point back to the controller. The on the star comma G, the incoming interface should point back to the RP. The outgoing interface should point down to those interfaces where the WAPs are. And yeah, and since the group is unique, if it's got other groups, if it has other interfaces on its outgoing list, you're going to be curious about that. Why is it doing that? Something's not right. And let's see, we are at time, so that's perfect. This is take 2 of this one, so hopefully I think I did a more coherent job the first one. Being a teacher, I always remember this was period 1. Sorry guys, when I was teaching, high school, yeah, I did my best, but I got to see things. You showed me things that didn't work well. You helped the rest of your class. Because of course I didn't stay in the profession very long, so I didn't have this body material I'd done 1,900 times. So, and this is new material. I'll do part 2 tomorrow, and then I'll finish the other half of this tomorrow, and then it'll be next week. I think the one I want to do, because I feel more comfortable with, is IPv6. I'm just having a little bit of internal debate about scope on it, just because I don't know how much IPv6 people know. So how much of a intro, right? I remember in the old days, kids, yeah, back when I was taking Cisco classes, when Cisco was much more primitive. Oh my God, every class, no matter how advanced, we did a whole unit on subnetting. And I have guys in my classes that couldn't subnet IPv4. They were hopeless. Like, oh, how do you know? I'm like, dude, this is an advanced class. What are you doing here if you can't do this? So, but IPv6, you have an excuse because it's not ubiquitous yet. So that's what I'm trying to figure out, which may mean it's a longer unit. It may be like a 3, segment unit, something like that, which may be good. And I have more classes next week. Anyway, thanks for joining. You have questions, put them in LinkedIn. Best place to do it. You can send me a message on LinkedIn. You could send a post. You can go to my YouTube channel. You could post on the videos. Aaron says, hey, I wasn't clear about this. Whatever, happy to answer questions. Non-Cisco questions, well, I may be able to give you kind of overall advice, like this is what you're looking for, but if you want sort of deeper advice, I'm like, send me a manual. Because they all do it differently. The commands are going to look different. The concept is the same. And I will say the challenge a lot is if their manuals are not very public, they're fairly well hidden. The hard part is Like, yeah, you gave me that. And it talks about multicast, but it doesn't tell you how you tell it where the RP is. How do I set up a BSR on that brand? I don't know. Not in this documentation. So then I may have to send you back for stuff. But I've done this kind of stuff for my friends in particular. But whatever. We're out for today. We'll see you, and thanks for watching.